Right, so I'm going to talk about C#9 record types. It's going to be a whistle-stop tour. I did a talk on .NET 5 actually last week, and it took 90 minutes. So this is like a very edited highlight of a tiny part of it, but it's a massive topic. So I'm gonna whistle through it. So strap in. Okay, I'm actually going to talk about a couple of other features on the way in that I think are relevant to record types. So first of all, very briefly, top-level statements, just because it makes your demos much easier to read and much shorter. So what you're looking at on the screen here is some code that's making use of the C#7 async main method. And you can see here we're using a bit of string interpolation on the args argument. I can take that code and I can strip almost all of the noise away and end up with this, which is a valid C#9 program that is using top-level statements. You'll notice that we can still use await, even though we've got no async and no main method, and we can still refer to the args argument, even though we haven't defined it anywhere. Behind the scenes, this is creating a class with a main method, and it's bringing the async and the args in scope. So it generates exactly the same code as what you just saw. It's just much lighter weight syntax, which is really nice. And I think that's true actually of a lot of the features in C#7, 8, 9. A lot of the newer features are really aimed at helping you write less code, make it clearer, just make it easier for developers to understand. Because after all, we spend probably 95% plus of our development time reading code rather than writing it. So I think anything that removes code is good. So let's look at init-only setters, which do a bit more of removing boilerplate. So we'll get there through a little bit of a historical journey. So this is a class from the land of C#1. Now you might decide or see here that we're using fields for of an ID and a name for person, and that's probably not the best idea, mostly because we're taking capabilities, the fact that we can access a name and an ID, and we're tying them very closely to our implementation choice of using fields. And that means that we can't perform validation, we can't perform computation. And you might think, well, perhaps I don't need them right now, and I'll change that later. But changing it later is going to break source, binary, and reflection compatibility. So most people would start out doing something like this in C#1, start with the property-based version. And back in those days, you really did have to do all the work. So we're creating our backing fields and writing all the code in our get and set accessors to make that work. C#2 didn't change things too much. It allowed us to have different access modifiers to getters and setters. So you'd often see a private setter being used in combination with a constructor to mimic immutability. So you probably add a constructor into this to give you that sort of immutable feel. C#3 then introduced automatically implemented properties or auto properties. And this would produce pretty much the same compiled IL as the previous code, but you'd have so-called unspeakable names used for the backing fields that you don't sort of see mentioned in the source code. So invalid C# identifiers, but they're fine for the .NET runtime to use. So C#3 only allowed read-write properties to be done this way, and this stayed the same until C#6. So you then commonly sort of see this kind of thing going on to mock immutability, where I can set these properties in the constructor. And then with C#6, you got to take away that private setter, and you could still make this code work and still set read-only backing fields in the constructor. So what I'd really like to do quite a lot, but I can't do in less than C#9, is write code like this, where I'm initializing read-only properties. This code wouldn't compile. But now with C#9, it's introduced the init property, which looks like this. And this would allow the object initializer syntax that we just saw to work whilst keeping immutability. So what init does is it basically extends the construction phase of an object to include that part where you do object initialization to give you a continued opportunity to set sort of read-only immutable fields. So if I just sort of take a slightly simpler example here, where we're just creating a foo class and giving it an ID property. Giving it that init syntax, then I can write code like this that would set the create a foo instance and set its ID property. I can do this and it would be quite happy. If I try to do this, modify the ID property of our new foo instance afterwards, then we're going to get an error. You'll see the CS8852 error, which tells you that you're trying to change an init only property after initialization has completed. So I think it's quite interesting at this point to look at what's going on behind the scenes. If you were to look at the IL of that foo class, what you're going to see that's sort of interesting and different is this modrec. So a modrec is a type of custom modifier, and a custom modifier it's a bit like an attribute, but it's something that actually forms part of the signature of a method in C#. It's used quite heavily in C++, not so often in C#. A modrec is something that the compiler has to be aware of. So init is actually changing the signature of a setter method here. And you can see it shows up here because it's part of the signature. It's not only showing up in the definition of the setter in the IL here, but you also see it when you call the class. So this is the main method where we're newing up our foo instance, and then we're making that call to the setter. And you can see it has to express the custom modifier, the modrec, in that code. So it's important to note that reflection over an init-only property will look like a setter and can even be called like a setter. So if you sort of get the property info off of an init property, you can change it post initialization. Looks no different for reflection purposes. And it's also a binary breaking change to change from an init property to a setter property. But for the most part, it won't break source compatibility. And if you go from sort of init to set, you're not going to run into too many problems because you can't compile against a C#9 init property class unless you've got a compiler that's compatible and understands this modrec attribute. So I thought it was interesting to look at a bit of some of the magic that's going on behind the scenes. And I think it's a useful side effect that things like reflection continue to work because it means the mechanisms that are used by a lot of ORMs and serializers and so on, JSON.NET, for example, continue to work as you'd want them to work when you're using these immutable properties. Okay, so let's get into records. So records are allow you to create it's a new reference type syntax to easily create immutable reference types with a structural value-based equality. So they have an equality behavior that feels a lot more like value types, but they're still reference types and they're stored, on the heap. So the easiest way to create a record is with what we call the positional record form of a record type. So the declaration of my record is here. It's the record person. And then we're following up with a parameter list, which gives us the properties that we want to put on that record. And with that in place, I can declare a new person like this. And one of the sort of features you get with the record, this write line, it has a two-string overload, which gives you this very nice sort of representation, which would sort of sit very well in logs and that kind of thing. So that's going to generate a reference type, a class with a person ID and a name property, which is an init property. So you can set it once at construction time, and then you can't change it. So the with initialization syntax gives you an easy way to copy and modify one of these record types. So here you can see I can spin up a new person, and then person 2 here is taking person 1, but with the name of Ben. So it's going to clone the person 1 record and then just allow us to modify the name records to create a new value. So records can be inherited as well. So here we're seeing a new employee record type that's being derived from the person type. And in order to do that, we need to sort of re-specify the properties that we want to be part of the employee and capture those so that we can invoke the constructor of the person record underneath. So as I mentioned, we get this value-based equality, which means that the code that you're looking at here, where we're declaring two separate person instances that have identical values, if you tried this with a class in pre-C# 9, then these things would not be equal because the default behavior would be reference equality. If you run this code, though, you'll find that you'll get true coming back because they share the same values. And finally, you get the ability to deconstruct the record. So it's actually a feature that's existed in C# 8. If you create a deconstruct method, then you can allow a type to be decomposed into its constituent parts. In this case, record types will synthesize a deconstruct method for you that lines up with the parameter list that you've provided after the type name. So here I'm taking a tuple. I'm actually using a discard syntax, so I'm only interested in the name. When I set this equal to person, it's going to invoke the deconstruct method and allow us to pull out the value of the name property into the name variable here. So what's going on behind the scenes? So records are very much a compiler feature. What gets spat out into the IL is a class. And it will create a whole bunch of stuff to give us all of the features that we've just seen. You can see that a record derives from implements IEquatable of T. In order to get the cloning functionality, it will synthesize a clone method, which will call a special copy constructor, which takes in the original person that we are going to clone, and then that will run through all of the fields of the type and copy them. Here's the syntax of the deconstruct method that supports deconstruction. You can see the overloads to fill out IEquatable and the equals and get hash code methods that are part of equality. There's also a property equality contract that exposes the type that you're using in a comparison. And the reason for that is that if you had, say, like an employee derived from a person that actually added no new fields, or you had two types that shared an identical list of field names, that they would not be equal under an equality comparison. And then we also have the print members, which does the nice sort of curly brace formatting of the field properties, and that's called by the toString overload that's synthesized to give that nice output. So we've been seeing that concise positional record syntax. You can also go ahead, open the curly braces, and extend the class with your own methods and properties, just like you can any class. And you'll notice here that includes adding in a mutable property. This isn't a get init, it's a get set. You can absolutely do that. So just be aware that just because it's a record doesn't mean it's immutable, doesn't mean it has to be immutable. The short form syntax will create init only properties for you, but you don't have to stick to that. And similarly, you can abandon the use of the parameter list altogether and just go ahead and declare init properties. And one reason you might want to do that is so that you can use an object initializer, so that you can choose to initialize any fields that you like and not rely on having to use the constructor. So if, for example, I declared my person like this and I added in my age property, if I wanted to have an initialization syntax without calling the constructor here, I have to do something like this and provide default values for the parameter list up here. And in fact, no constructor you add, every constructor you add has to have a call to the this constructor that's created for the parameter list. So what you end up then really with is a syntax that has near zero noise. I think the only superfluous thing in this line is probably the punctuation, the comma and the semicolon and possibly the brackets they could get rid of next, but that would probably make it just not C#. So key points, I'd recommend using the default syntax if you can, just because it's super lightweight. JSON serialization and deserialization will continue to work. You can break immutability, but I would say probably don't do that to avoid surprises. And you can absolutely extend these to add custom methods. Good key use cases are DTOs, return types and API controllers, data logging, data comparison. And because they're naturally immutable, unless you break that, that's really good for parallelization and immutable collections and so on. And that, in a nutshell, is record types. I think I've just used my time. I believe we're going to hear from Phil now about Visual Studio extensions. And if you've got any questions, pop them in the chat and I will deal with them as I see them. Thank you all.